dots are present. So compare A with D, right? At 4 hours, you see a big change, a diminution in the amount of fibrils present as evidenced by the fluorescence signal. You can see fibrils with your eye. The solution is cloudy. But if carbon quantum dots was present prior to the formation of fibrils, the solution remains clear. So essentially, these carbon quantum dots have arrested the soluble to toxic transformation of NA white lysozyme. So this is a prototype, right? The next thing to do would be to use amyloid beta, which is much more expensive, or tau, alpha synuclein, mutant Huntington, and test whether the same effect is manifested. Well, what happens if you already have fibrils in your brain? So we have mature fibrils in a fluorimeter and we added THT to it. So the black curve in A shows what happens when THT is added in a fluorimeter to a cuvette containing fibrils. You have an on rate, right? The THT is coming onto the fibrils and you have a nice increase in fluorescence. Now you follow A and then you come back to the purple line. What happens to those fibrils which are already present when we added the carbon quantum dots? You see a diminution, a decrease in the THT fluorescence, suggesting that the fibrils dissolve, right? So we were very excited. Now the reviewer is always smarter than me. I don't know about you, but he's smarter or she's smarter than me. So the reviewer said that what you're saying is fine, but it would simply mean that the THT which was intercalated with the fibrils was knocked off by the carbon quantum dot. That means the fibrils are still there, except there's no reporter. And if there's no reporter, you're blind to what's happening. That night, my son had a tough time. He didn't know why dad was so angry. Okay. So again, I don't know who's married, but those of us who have children, our kids are the whipping boy or whipping girl for whatever happens in the department. All right. So when your parents come home angry, it's not about you, it's what happens in the office. The first 2 rows, and we realized that the reviewer is right. What can we do? So we need some other technique to make sure that it's not the carbon quantum dot knocking off the reporter from the fibrils. Fibrils are still there. So what do we do? Well, we have DLS, right? So A, top left is your carbon quantum dot, top right, NA white lysozyme. At the bottom left, we have a mature lysozyme fibril. Look at the size of that beast. It's about 8,000 nanometers. Look what happened when we added our carbon quantum dots. It immediately started breaking down the fibrils. Now, this is a one-time deal. You can't be satisfied. You have to do what's called a dose dependency in every experiment and a time dependency. But we were excited by that. And then we also used AFM. So you can actually see a fibril there. And look what happens when we add the carbon quantum dot. You have the silicon wafer background, right? So these carbon quantum dots were able to dissolve the fibrils. So now we not only have fluorescence, we have size, and we have actual data looking at these fibrils using an AFM. Of course, the AFM costs a lot of money, and we don't have the luxury of doing one afternoon experiments like we can do in the fluorimeter or DLS. The outcome of this is what we in the profession like. So we have a publication. Eric Daniel Burero was an undergrad BS student. He is now at UT Southwestern, which is a premier school, doing, and he's an NSF fellow, right? He gets paid by the National Science Foundation to do his organic synthesis. He's moved on there. Angela Marquez, so other Hispanic serving institutions, these are all Hispanic names. She was a high school student, and now she is what's called a physician's assistant, PA. Jyoti Alawat, she was in IIT Roorkee, Gopinath Patriswamy's lab. She went on to do a PhD with me. She's now in industry. So we got a nice paper there. Right? Now the NIH, the National Institutes of Health, needs something that's called translational work. Not satisfied with test tube experiments. They'd like to see what happens in cell lines. So we try to induce Parkinson's disease, which is associated with alpha synuclein aggregation using this mitochondrial poison called paraquat. it's it's a herbicide and a pesticide. So that paraquat molecule shown there, it creates reactive oxygen species, and it initiates a cascade of events that leads to the Parkinsonian phenotype in cells. Now the cells can't have tremors, so all we can say is that on the Parkinsonian phenotype, that means aggregated proteins. So we use paraquat. So this is the paraquat toxicity. You can see that paraquat is very toxic on the right side. And when we have carbon quantum dots present, the toxicity of carbon quantum dots is pretty negligible up to high levels. And eventually, when we poison the cell with paraquats, but we have pre-incubated the cell line with carbon quantum dots, these cells are insulated from paraquat initiated cell death. We then use what's called a C. elegans worm model. Before COVID, we used to work with rats, rodent Parkinsonian model, but we have stopped working with rats and we have worked with nematodes, C. elegans. So you can have these transgenic worms. They are tagged with dopamine, sorry, they are tagged with GFP in their dopaminergic neurons. So you can see them under confocal microscopy. Let's see if this plays. You can see the worms moving in an agar plate. Okay. So this is under light microscope. If you look at it under fluorescence microscope, you would see that the worms are green in color. So what have we done? We have poisoned the worms with paraquat and the worm lifespan decreases. If you treat the worms with carbon quantum dots, top right, the carbon quantum dots are tolerated by the worms. The yellow line is the 2 millimolar paraquat control. You have demise of these worms, paralysis and death of the worms, but our carbon quantum dots are tolerated well. And then finally, when we are